Today you will be finding linear regression models. So the linear model, this is the equation of a straight line through the data array. It summarizes the general pattern. And the least squares regression line, this is our best fit model for the data. We use it to predict outcomes, and slope indicates association and rate. So for example, if the slope is positive, then we have a positive association. And rate would be like your slope, so your change in y values over the change in x values. So let's look at an example. So let's say we want to consume 25 grams of protein for lunch. How much fat should you expect to consume? And notice we're at Burger King. We have a nice scatter plot with a line through the scatter plot. Notice protein is our explanatory variable, fat is our response variable, and let's move on. So remember linear regression equations? Well, they're written in slope-intercept form. Okay, so this is the equation that we will use. We will use the y hat equals mx plus b. And that y hat, all it is our predicted y value. To find the y, remember this is the value of the response variable, whatever on your scatter plot we place on the y-axis. And the x is the explanatory variable, whatever we place along the x-axis. To find the slope, we will use the equation m equals r times the standard deviation of y over the standard deviation of x. And to find the y-intercept, we will use the letter b and set it equal to y bar minus m times x bar. So let's say we are given the data from Burger King. So a couple things that we should note. We're given the x bar. We're given the standard deviation for x. We're given the y bar. We're also given the standard deviation of y. And notice we're also given the r value. So we will need to have these 5 values in order to do our analysis. After we've identified our 2 variable statistics in r, we will find the slope. So remember, we are going to be using that slope formula. Remember, our slope formula is m equals r sy over s sub x. So if we were to look at that, notice our r value is 0.83. Our standard deviation for y is 16.4, and our standard deviation of x is 14. And it gives us a slope of approximately 0.972. The next thing we'll do is we'll find the y-intercept. So notice that what we did for y-intercept is we start off with the mean for y. We're going to subtract our answer from the slope, so 0.972, and multiply that by the mean for x. And type that into a calculator, and notice we get 6.782. The last step is to write the equation of the line. So note we have y hat equals 0.972x plus 6.782. So again, we're using our data from Burger King, and notice our model that we just found we have written here. And our question says, how much fat would you expect to consume with 25 grams of protein? Well, remember protein was our x variable. So if I want to know how much fat we would have, we would replace the x and put 25 in its place. Okay. So note we just replace the x value with a 25, and now we're going to type that into our calculator. It should give you about 31.082 grams of fat. So notice in your example you try. In a professional soccer, it's all about scoring goals. The number of games that a team wins is strongly correlated with the number of goals the team scores, then with the number of goals the team surrenders to its opponent. For the 2013-14 Premier League in England, the mean number of wins per team was 15.1 and standard deviation of 6.73. So I see mean and standard deviation. And then notice as we continue reading, It says the mean number of goals scored by a team was 52.6 with a standard deviation of 20.62. And notice it also gives us the correlation between the two variables. So the correlation was R equals 0.889. It says we're going to find the equation of the least squares regression line for predicting the number of wins from the number of goals scored. So the first thing you'll want to do is you'll want to find the regression model, and because it says we want to predict the number of wins are your y values and the goal scored is your x values. Find the regression model. As you can see from our regression model, our slope is about 0.290 and our y-intercept is negative 0.154. So therefore our model is y hat equals 0.290x minus 0.154. The second part of our example says we're going to predict the number of wins from 22 goals scored. Try it. Hopefully you found a prediction of 6.226 wins. Let's look at another example together. Ms. Z wants to see if there is a strong association between the number of days the student misses and the student's semester grade. She collected data for 5 of her students. So notice we've identified number of days absent and the semester grade in percent, and we've labeled number of days absent the x variable and the semester grade is the y variable. And our statement says we're going to find the equation of the least squares regression line. First thing we'll do is we will enter our data into our calculator and find the values necessary to use the formulas. Meaning we need to find the mean for x, the standard deviation for x, the mean for y, the standard deviation for y, and r. Try it. When you run your two variable stats or you use decimals to obtain the values, notice we have the mean for x is 12, the standard deviation for x is 10.10, the mean for y is 67, and the standard deviation for y is 21.35. Our correlation is negative 0.94. Our next step is to find the slope. Remember, for slope, we're going to take the r value times the standard deviation for y divided by the standard deviation for x. Once we use our calculator, notice we get a slope of negative 1.987. Next, we're going to find the y-intercept. Remember, you'll take the mean for y minus the slope we found in step 2 times the mean for x, which in this case is 12. And we would type that all into a calculator and get around 90.88844. The last step is to write the slope and y-intercept in the form of a line. So y hat equals negative 1.987x plus 90.844. So notice we have the same situation. We have our days absent and semester grade, and we have our model in the thinking bubble we found on the previous slide. So what grade could a student expect to get if they miss 14 days of school? Well, the 14 days of school, what variable does that go with? Hopefully you recognize that means our x value was 14. And we're going to use our model from the previous slide to obtain the semester grade. So notice we're going to take our model and we're going to replace the x with the 14. I don't know why there's a hat over the 90.844. It should not be there. When we use the calculator to obtain our predicted value, notice we do get around 63%. The last thing we need to discuss is extrapolation. This is when our model predicts values beyond the given data. It can be inaccurate. For example, if we're talking about age versus height, typically we say there is a positive association between height and age, but eventually people will stop growing. So if we wanted to use a model to predict how tall an individual would be from childhood to adulthood, but we end up having a 55-year-old person, the prediction is unrealistic because that 55-year-old person stopped growing quite a while ago. Another example would be days shopping versus money left in the bank. Normally we say there is a negative association in this example between days shopping and money left in the bank, but if this trend continues, you could have negative money in the bank, which does not exist. The end. It's practice time.